Okay, guys, we're going to start circles this week, and you need to know some formulas for that and what pi is. And you're going to use the pi button on your calculator. So the first thing we're going to talk about is the terms. So the first thing is circumference. So circumference is the distance all the way around the circle. So that's like the perimeter of the circle, okay? So the perimeter of the circle, that's the circumference. And you find that by using the formula circumference is equal to pi times d, or circumference is equal to 2 pi r. Okay, so that's the formula. So you would plug everything into that formula. And we're going to do some examples with that. Okay, you also will find area using the formula. Area is equal to pi r squared, r meaning radius. We'll get into that a little bit later in the video. Diameter. So talking about the terms, so circumference is the perimeter all the way around the circle. Diameter is the measurement straight across the circle from one point to the other all the way through is the diameter. The radius is from the center point of the circle to the outer edge. And the radius is always twice the diameter, okay? How do you find pi? Pi is found by taking the circumference and dividing that by the diameter. And you probably already know this, but pi is one of those numbers that is irrational, and it will repeat on and on and on forever. So this is rounded. Rounded pi is 3.14. You can also use 22 over 7 as a unit for pi. So looking at, this is out of the Go Math packet. A circle is a set of points in a plane that are fixed distance from the center. Okay, so the radius is a line segment with one endpoint at the center of the circle. As you can see, the center is marked there. And the endpoint is on the outer edge of the circle. The length of the radius, that length is called the radius. A diameter of the circle is the line segment that passes through the center of the circle, whose endpoints lie on the circle. The length of the diameter is twice the length of the radius. The length of the diameter is called a diameter of the circle, so it goes straight across all the way. And the circumference is the distance around the circle that we already explained, so that would be the perimeter. So when you find circumference, this is the ratio, the ratio of the circumference to the diameter, that's pi. And I told you you could substitute 22 over 7 for pi, or use the pi button on your calculator, okay? You'll use circumference equals pi d as the formula, or 2 pi r if you know the length of the radius. Those would be the two equivalent formulas for circumference of a circle. So if we look at this one, it's an example. It says the irrigation sprinkler waters a circular region with a radius of 14 feet. Find the circumference of the region watered by the sprinkler. Use 22 over 7 for pi. Well, so here we have circumference is equal to 2 pi r. And they're telling us to use 22 over 7 for pi. So it's going to be that times 2 times 14 for our formula. So it's going to be circumference is equal to 2 times 22 over 7 times 14 over 1. So I'm going to cancel this out. 7 goes into 7 once, 7 goes into 14 twice. So now it's 2 times 22, which is 44, times 2, which is 88. Okay? And I'm going to address that here in a second for you. So here it says analyze relationships. When is it logical to use 22 over 7 instead of 3.14 for pi? Well, whenever the radius or diameter is a multiple of 7, that's when that works. So in the previous problem, the radius, was it radius? Let's see. Yeah, the radius was 14. So that means the diameter would be 2r. So if the radius was 14, that means the diameter would have been 28. So if I can use circumference is equal to 2d, so the circumference, I lied. Circumference is equal to pi d, whoopsies. if I use 22 over 7 times 28, when it's a multiple of 7, that's when you can use that cross simplifying to simplify. And you can multiply a lot easier if you're not using a calculator. So 7 goes into 7 once, 7 goes into 24 times. Then I know that 22 times 4 is 88. That's how we got 88 for the circumference of the previous problem. So whenever the radius or diameter is a multiple of 7, using that 22 over 7 is easy because you can cross simplify and then easily just do the multiplication by hand instead of using a calculator. So here we have this example, and it says, find the circumference of a circle to the nearest hundredth, and it says circumference is equal to pi d. That's our formula, and if we can see here that the radius is 11, then I would use my calculator, and I would use the pi button, and I would say that times 11, and then I would get a circumference of 34. When I put it in, I get 5,600 centimeters. That's why they have that about word there. So that's how we would get that circumference. Using circumference, given the circumference of a circle, you can use appropriate circumference formula to find the radius or diameter of the circle. And you can use that information to solve the problems. So what we mean by that is the circumference is equal to pi d, or the circumference is equal to 2 pi r. So in a problem, if they give you the value of the circumference, and then you're trying to solve for the radius or the diameter, you're just going to plug those values into your formula, and then you'll use algebra to isolate for d or r to find that value. Okay, so we're going to do a couple examples like that. So here you can see that they're telling you a circular pond has a circumference of 628 feet. A model boat is moving directly across the pond along a radius at a rate of 5 feet per second. How long will it take the boat to get from the edge of the pond to the center? So they want us to find the radius. That's what they want us to solve for. So using that formula, circumference is equal to 2 pi r. They're telling us the circumference is 628 feet, so I'm going to plug that in. And then 2 pi r. So what I'm going to do now is I would take 2 times 3.14. So I have 628 equals 6 28 times r. So then I would divide by 6.28 on both sides to isolate r. And I would get 100. And we're using approximately equal to because pi is not exact when we use 3.14. Is approximately equal to r. So the radius is about 100. It's telling us then they want to know if it goes 5 feet per second, how long will it take to reach the middle? Well, so I would take my 100 and divide by 5. When I do that, I get 20. It's going to take about 20 seconds to reach the middle. Okay? So again, you're just using that formula, plugging in what you know to solve what you don't know, which is r. Okay, let's look at this word problem. A museum groundskeeper is creating a semicircular statuary garden with a diameter of 30 feet. There will be a fence around the garden. The fencing costs $9.25 per linear foot. About how much will the fencing cost altogether? All right, so what's important here? They're creating a semicircular garden with a diameter of 30 feet. The fencing costs $9.25 per linear foot. I guess we should say a fence around the garden. So we're trying to find the cost. Well, what's really important here is semicircle. A semicircle is a half circle, because semi meaning half. So that means our circle is going to be like this, a half circle. So the first thing that we have to do here is find the circumference of the circle, okay? So the circumference is going to be equal to pi d. So that would be finding the entire, pretend that's a good-looking circle, okay? Circumference all the way around. But we don't need the whole way around. We only need half of that, okay? So we're just looking for this much of it, the green there, okay? So that means I'm then going to divide this by 2, okay? So my circumference is going to be equal to pi times the diameter, which is 30 feet, divided by 2. So I'm going to put that in my calculator. And when I do, I'm going to get 47, that looked bad, 47.12, okay? However, so that's feet. However, it has a diameter of 30 feet. That means, and they're going to fence it all the way around. That means they have to fence this too, which is 30 feet. So I'm going to have to add that to it, that 30 feet. Because right now, half the circumference is only this portion. I'll do it in red. That's only half the circumference. So I'm going to have to add this 30 feet of the diameter to close the garden in with the fence. So I'm going to take that plus the 30 feet. Okay, so then that circumference of the half circle garden is going to be 77 1200 feet. So then I'm going to take that 77 1200 and I'm going to have to multiply that by the $9.25 it costs for the fencing per foot, and I'll get a total cost of $713.40. Okay. Just a couple of number sense things that go with this. So this one says Dante checks the answer to step 1. So this was a problem with a radius. And it says multiplying by 6 is comparing the circumference. They want to know the given circumference. They want to explain why Dante's estimation was correct. So this goes back to that problem that had the circumference was equal to 628 feet. Well, the reason why this works is that if you think of that formula, circumference is equal to 2 pi r, okay? And you know then, we knew that the circumference was 628 feet, right? Oh, I wrote 682. Was 628 feet. 2 times pi is super close to 3, right? 3.14 when we estimate it. So 2 times 3 is 6, right? So 628 is equal to 6, and the radius was 100 on that one, times 100. Well, that's 600. So 628 is really close to 600. That's why that number sense works there. So you should be asking yourself, if the radius is 100, and I'm using 2 pi r, and pi is close to 3, and 2 times 3 is 6, 6 times 100 is 600, that's really close to 628, my answer makes sense. Okay, so I definitely wanted to go over that to kind of put that number sense in your head. So comparing finding the area of a circle when the given radius of the area is the diameter. So I'm going to skip this and come back to it after we talk about area of a circle. So here, oh, we just talked about that one. We did that one. Okay, so the area of a circle is found by taking the formula area is equal to pi r squared. Okay, so you're just using the information given like you did it for circumference, and you're plugging in the formula for area. So area is equal to pi r squared, but you'll have to use exponents this time. Okay, so I'm going to go back to that one. So it said compare finding the area of a circle when given the radius with finding the area when given the diameter. Well, the formula for area of a circle uses the radius of a circle. If you're given the diameter, you're first going to have to divide by 2 to get the radius. So if you think about that, here you have your circle. The line going across would be the diameter. The area is equal to pi r squared. So you need to use r squared in your formula. So if you're given the diameter, you'll have to take the diameter and divide it by 2 to get the radius. Then you'll use that in your formula, okay? So I just want to make sure if you only know the diameter, you're going to have to divide it by 2. Okay, so again, finding the area of a circle is going to be equal to pi times the radius squared. So, and also remember that areas in square units. That means if it's feet, you're going to have to square it. If it's inches, you're going to have to square it. If it's centimeters, square it. Meters, square it. Always use square units for area. Okay, guys? Here's an example for you. A biscuit recipe calls for dough to be rolled out in circles to be cut from the dough. The biscuit cutter has a radius of 4 centimeters. Find the area of the top of the biscuit once it's cut. Use 3.14 for pi. So what's important in this problem is that it has a radius of 4 centimeters, and we're finding the area of the top of the biscuit, and the biscuits are circles, okay? And they want us to use 3.14 for pi. So area is equal to pi r squared. The area here is going to be equal to pi, well, they told us to use 3.14, so we can just plug that in. 3.14 times 4 squared, okay? So area is going to be equal to 3.14 times 16. So the area is going to be 50 and 24 hundredths centimeters squared on the top of that biscuit. Okay, so again, formulas are really easy. Just plug in what you know and solve it. Here we have one that says 2 circles have the same radius. Is the combined area of the 2 circles the same as the area of a circle with twice the radius? Well, I know that's a lot of confusing words in one problem, so let's talk about what it was actually asking. So 2 circles, and they have the same radius, okay? So I have a circle here, they both have the same radius, okay? They want to know if the combined area, so that means I would add it, right, is the same as, or multiplied by 2, is the same as the area of a circle with twice the radius. So you're talking about a bigger circle, right? So let's talk about that. So say I have the radius of these circles is equal to 2, okay? And let's say the radius of this circle is equal to 4. So this one's twice that one, right? 4 is twice 2. So let's go here. Area is equal to pi r squared. So that means area is equal to 3.14 times 2 squared. Area is equal to 3.14 times 4. So area is equal to 12 and 57 hundredths. So that's one circle. So I'd have to multiply that by 2 to get the combined area. So that's going to end up being 25 and 14 hundredths for the combined area. So if I go over here to the area with twice the radius, area is equal to pi r squared. Area is equal to 3.14 times 4 squared. Area is equal to 3.14 times 16. Area is equal to 50 and 26 hundredths. So actually, the area of the one with twice the radius is actually almost double the area of the previous, the combined area of the radius that's half of it. So the answer here is no. The combined area would not be the same. The answer is definitely no. Okay. So I guess the biggest thing to learn about the circles is definitely use the formulas, use the pi button on your calculator, look for those multiples of 7 for the circumferences, and use that 22 over 7. If you use the formulas, you really can't go wrong. Okay, thanks guys.